Algebra 1, Section 5.1, relating graphs to events. Basically interpreting graphs and interpreting situations and drawing a graph based on a situation. And we're looking at this first example. It just says describe what this graph shows by labeling each part. And the first critical thing you must understand about a graph is what's being charted out. Notice that this is as time goes on. Notice that this is distance from home, okay? So, and the title is walk in a neighborhood. So we're talking about somebody who's walking, and as time goes on, their distance from home is doing what you see in the graph, okay? Notice that they finished where they started. That means that they arrived back home, okay? So what do you make of this first section? And again, I'm going to try to keep this video short, so if you want to pause and think about it, that's fine. What do you make of this first section? I would suggest you to this first section is that they are speeding up, right? They're walking and they start out walking slow, but then as time goes on, the distance that they're traveling seems to be increasing over time. So I don't know what I didn't look at this and see what the software labeled this, but I would say that this is maybe like a warm-up walk where they're speeding up. Okay. Now, what do you think of this? Again, pause it if you don't want me to answer too quick. What do you think of this right here? The distance from home as time goes on is not increasing. Did they stop? I'll give you two options. They stopped. Maybe the dog had to do its business, or maybe they stopped to talk to somebody. You don't know. One other possibility, this is an unlikely possibility, but let's just assume this is home and you walked away from home a certain distance, and then you continued to walk, but you did not, but your distance from home didn't change. This would be known as a circle, right? Now, I doubt it. I mean, I could find you a neighborhood that probably is this structured this way, and that could be the possibility, but that's probably not what happened. They probably stopped to talk to the neighbors or something, right? And then, so this is, I'm going to say stop. I'm going to say the same thing about that right there. This then would be walking at a steady rate, further away from the house. So let's say steady away, whereas this is going to be steady coming back. Okay. I think stop would also go for this one right here. And then this last one, you've got a little bit of a curve right here, maybe even like a cool down, like they were walking faster at first, and then as they approached home, they slowed up at the end. I don't know, cool down walk. I have no idea what the software is going to label these things. This is just what I'm thinking of. Walks slowly, walks quickly. Okay, so they labeled, yeah, okay, I can get down with that. And stand still. All right. Next one, sketch a graph of the altitude of a pelican from takeoff from shore to diving to the water to catch a fish. Label each section. So think about that now. What would you label the axes first of all? Sketch a graph of the altitude of a pelican from takeoff from shore to diving to the water to catch a fish. Well, clearly the one would be the altitude. The vertical, I think we would all agree, would be the altitude. I think the other one's just going to be a time again. They didn't really outline that here, but what else would it be, right? As what elapses, the pelican is going to have different altitude, obviously time. So I would say something like this. The pelican is going to gain some altitude, hover at the same altitude for a while, and then eventually dive for a fish. Okay, now that's a poor drawing. This is, and I want to keep the video short, so I'm not going to write it, but this is gaining altitude. This is not hovering, but flying at the same height, searching for fish, and this is diving. They're going to have something very similar here, I believe. Yep. Take off, searching for fish, dive to water. Of course, this is section 5.1, the introductory lesson to chapter 5. So this is kind of basic stuff, but foundational nonetheless. So make sure you understand each section here. One more. Suppose you drink the remaining soda from a can in 10 seconds at a steady rate. Describe the graph of the change in height of liquid over time. So again, And I'll just do the graph. We can describe the graph. I can just do the graph. This is time. Now you might think, hey, why don't we put 12 ounces right here? After all, it says that it's a can of soda. Most cans of soda are 12. I know that they make smaller ones, but most cans of soda are 12. You might think, hey, put 12 ounces right here, but that's not what it says. Describe the graph of the change in height of the can. Now, if we were actually to be able to measure the height, I guess you'd have to suck it through a straw, but yeah, this is what they give us. So I would say no. And it also says the remaining soda. So it's kind of like there's already some missing, like you've already taken a few drinks. So I don't know what this is. I wouldn't put a scale to this. We do know that it's height. I just wouldn't say how high it is. And it's definitely not ounces. But if this is where we start, and it's at a steady rate, we would know that this is 10 seconds. Okay. Now let's look at their description. I just went for the graph itself, but their description says the graph would be a straight line from the original height at time 0 to 0 height after 10 seconds. That's exactly what we showed on our graph there. All right, that's it.